Hello there, general science students, and welcome to our video lesson covering 16.1, 2, and 3, the entirety of chapter 16, which is basically all about atoms, elements, and the periodic table. Okay, we're going to start off here by looking at some basic information regarding atomic structure and elements. All right, and we've been looking at the atom for a while now, okay, or we've been referring to the atom for a while, and the atom defined, as we've defined it in class, is the smallest structural unit of matter. It is the thing that makes up stuff, if you will, okay? If we were to just keep saying, well, what's that made of? Well, what's that made of? Well, what's that made of? After we get an answer to each one of those questions, when we finally get down to it, the smallest unit that makes up everything is the atom. All right, it's the smallest structural unit of matter, and it's also made up of smaller units, though. We didn't know this originally, but we found this out about 100 years ago, or we started to discover this about 100 years ago. Okay, we have subatomic particles that also help compose this atom. All right, protons, neutrons, and electrons are our subatomic particles. Okay, now placement of these three, or where they are located in the atom, is very, very important. Protons find themselves in the center or the nucleus of the atom, okay? And they have a positive charge. Neutrons, on the other hand, are neutral in charge or have no charge, and they are located also in the nucleus of the atom. Finally, electrons, negative charge, and they orbit around the nucleus, okay? We often refer to electrons being housed in electron energy levels, or electron energy shells, or the electron cloud, okay? Regardless, electrons orbit, move around the center of the nucleus in a generalized area, all right? General atomic structure looks a little something like this, and this would be the element, or the atom, hydrogen. Notice that hydrogen has an atomic number of 1, which means it has 1 proton. And if you have 1 proton, you also have 1 electron. The numbers of protons and electrons equal each other. Here would be considered the nucleus, all right, where the neutron and the proton are located right next to each other, and the electron moves around the outside of the nucleus. Pretty simple stuff, okay? Atomic structure and element basics, a little more here. Atoms to elements. Anytime we have one or more of the same atom, it's referred to as being an element. And again, we've got a specific amount of protons in each one of these different elements that give these elements their special characteristics and special traits, okay? Because oxygen has 8 protons and 8 electrons, it's different than nitrogen, which only has 7 protons and 7 electrons. It's different than chlorine, which has 9 protons, 9 electrons, okay? So it's the number of protons and electrons that give these elements their specific and specialized traits. Smaller structures that make up the subatomic particles of atoms, we call them quarks. Okay? Repeat after me. Quarks. All right. I kind of consider them the subatomic particles. There's 3 quarks that make up the proton and 3 quarks that make up the neutron, and scientists are still currently trying to search and find the actual substance, if you will, that holds these quarks together, and we're going to further even understand the smaller level of the atom. All right? How do we find these quarks? By smashing protons together and tracking the destruction of the proton. We were able to actually measure that the proton was indeed composed of these quarks. All right, pretty interesting stuff, and there's a fantastic PBS documentary about this information right here. Maybe we'll check it out sometime. Okay, a little history of the atomic model here, real fast. You can check page 492 in your textbook to show some diagrams and some pictures. But again, you start to notice a lot of activity around the turn of the 1900s, okay? So about the turn of the 20th century, we've got a lot of activity. 1904 with Thomson's new model, 1911 with Rutherford, and 1913 with Bohr, and then finally, just a little while after that, the electron cloud model has been presented to us. So we'll take a look at these in class, all right? And that is all I got for you guys in this little video over atomic structure and elements. or excuse me, not this little video. Rewind that. That's all I got for you with this note sheet right here. Let me go get the other one. Ha 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 ha, we still have more. And let's continue on with the periodic table of elements. Discovered and credited the discovery to a guy by the name of Dmitry Mendeleev, some Russian, so if you want to try to pronounce that with a Russian accent, go ahead. What he did was he started to experiment with elements, and he noticed that there was a similarity between their chemical and physical traits if they were close in atomic masses. Okay, so he took these elements and said, all right, these atomic masses are about even, and I'm really starting to recognize that they share some similar traits, both physically and chemically. He started to place them based on increasing atomic mass in his periodic table of elements. The rows were increasing mass, and the columns were based on similarities and properties. And what he predicted that it would look like in the future was fantastic. This guy was spot on, almost, very, very, very close. Okay. Anyways, take a look at his periodic table of elements in your textbook there. And we're going to be constructing and organizing our own with the mini lab that goes with this little video lesson. Today, though, we place each element in a box, and it's within that table. Each box usually has the name of the element, the atomic symbol of the element, the atomic mass of the element, and also the atomic number. And the atomic number tells us how many protons it has. And if you know how many protons it has, then you know how many electrons it has. The atomic mass is the mass of all subatomic particles, which typically ends up being just neutrons and protons because electrons are so small. Okay? It's the number of protons, again, can't say it's enough, that defines or makes that element that element. It's what makes it different from others. A little bit here about the periodic table of elements. Everything you see highlighted in pink, we call those the metals. All right? Typically, they have characteristics of malleability. They are ductile, and they usually exist in nature in the solid state. The things that you see in yellow are metalloids. Have both metal and non-metal-like characteristics. Could occur as gases, could occur as liquids, could occur in solids, could occur in slightly what would be, in our terminology now, non-Newtonian-like states, but they've got a little metal and a little non-metal with them. And then finally, the green highlighted, as you see, your non-metals, okay? Your non-metals. Very, very poor conductors. Sometimes good insulators, typically gases and liquids, but that's what we've got for the periodic table, and little descriptions here for each one of those highlighted areas. So a little introduction into the placement of elements on a periodic table and what we're kind of looking at in the various areas. All right, and we'll dive into that a little bit more in class. Okay, looks like I had some worksheets that we assigned in class last year with that. That's all I got for you here, guys, in this video, okay? That's all I got for you. What we're going to be doing in class with the information from this video is we're actually going to be modeling some atoms, okay? So we're actually going to construct some atomic models. We're going to organize a periodic table of elements with some mythical make-believe elements that we're going to practice with, okay? And then we, as a class, will go through the periodic table of elements and talk about the different columns, the different periods, the different groups, and the characteristics and traits that each one of those have. Okay, so we'll kind of go through it as class. That's all I got for you. See you later.